Clinic. Today we want to solve indices of a radical simple equation. This is s raised to power 5 over 3 plus 2s raised to power 4 over 3 minus 3x is equal to 0. So before solving this question, don't forget to subscribe to this channel and follow us in our Facebook page and the TikTok page profile. So now as we are solving this, we are going to explain step by steps. Let's try to watch this video to the end. You're able to gain from this. It is even more than a very simple radical equation. Now, in solving a question like this, the first thing you are going to consider, it is the powers of this x. What are the powers? We have 5 over 4. 5 over 4 can be written as one whole number, 1. This is 5 over 4. 5 over 3 can be written as one whole number, 2 over 3. Now, if this is this, and at the same time, this is a mixed fraction. So, in the place of mixed fraction, let's try to turn it to have 1 plus 2 over 3. So, by the time you add this, it will surely give us this. So, and this will surely give us an improper fractions of this. So, we also have 4 over 3. You have to consider this again. And the 4 over 3 can be written as one whole number, 1 over 3, which is the same thing as 1 plus 1 over 3. So, we are bringing out this analysis so we can use it to solve this problem. So, now, instead of writing s raised to power 5 over 3, let's write s at the power of, this is 1 plus 2 over 3, now plus 2x onto 1 plus 1 over 3 minus 3x raised to power 1, which is equal to 0. Now, but you can recall a loss of indices let us to know that a raised to power m times a raised to power n is the same thing as a raised to power m plus n. Now, if we're able to see this, this is multiplication, this becomes this. So it is applicable to this now. So meaning that x, it will give us x raised to power 1 dot s raised to power 2 over 3. Now plus 2, it will be x, the one will come here, dot s raised to power 1 over 3 minus 3s raised to power 1 is equal to 0. So all the s raised to power 1, let's rewrite it better to have x onto s raised to power 2 over 3, now plus 2x onto s raised to power 1 over 3 minus 3x is equal to 0. So if all this, you also observe that x are common. But before then, we consider this. Let's try to expand x raised to power 2 over 3. We can expand this to have s raised to power 1 over 3 all square. But we can still remember a law, which the law let us to know that a raised to power m at the same time raised to power n. That is the power rules. So which is a raised to power m times n. So let us to know that this times this will surely give us this. So in bringing of this, let's rewrite this. We have x onto, instead of writing s 1 over 3, you can write square. Now, plus 2x onto s onto 1 over 3 minus 3s is equal to 0. Now, as I've observed the other times that the s is common. Now, you now have x is common. We have s to the power 1 over 3 all square plus 2 onto s onto 1 over 3 minus 3 bracket close is equal to 0. As s is common, but we still have issue with this, let's represent k to be equal to s raised to power 1 over 3. So let's rewrite the equation again. We have x onto k squared plus 2k minus 3 bracket close is equal to 0. So now this is area we are now going to. So if two variables multiply to give us 0, it means it is s is equal to 0 or k squared plus 2k minus 3 is equal to 0. So this has formed a quadratic equation. So since it has able to have formed a quadratic equation, let's try to find the value of k. But you're able to see that this is a plus 2 and minus 3. What we are going to multiply to give us minus 3, and you add it together to give us plus 2. So it can be given as k squared plus 3k minus k minus 3 is equal to 0, because by the time you add these two together to give us plus 2k, the coefficient by the time you multiply plus 3 minus 1, it will surely give us minus 3. So therefore, let's try to group it. We have k is common. We have k plus 3. Minus 1 is also common here. We have k plus 3 is equal to 0. So let's proceed from here to have. Now, if this is this, let's try to now use it to have k minus 1 onto k plus 3 is equal to 0. So if these are the two factors of this quadratic equation, and I'm able to say that when two variables added together and multiplied together and give us 0, it means it is either k minus 1 is equal to 0 or k plus 3 is equal to 0. K is equal to 1 or k is equal to minus 3. But from the beginning, I said that k is equal to this. So when k is equal to 1, let's consider that when k is equal to 1 and the k is s to the power 3, so meaning and k is equal to s to the power 1 over 3. So we have 1 is equal to s to the power 1 over 3, and s to the power 1 over 3 is equal to 1. So for finding the value of s, let's find the cube of the both side. Find the cube of the both side. We have raised to the power 3 onto 1 raised to the power 3. You know, according to the power rules, this will cancel this. X will be 1 times 1 times 1, which is equal to 1. So that is the value of another value of s. So we're able to get the value of s to be 0 from the beginning, that s equal to 0. Let's also find another value of x from this quadratic equation. So when k is equal to minus 3, when k is equal to minus 3, and you know that k is equal to s to the power 1 over 3. So minus 3 is equal to s to the power 1 over 3. S at the power of 1 over 3 is equal to minus 3. So let's find the cube of the both sides. So 1 over 3 all raised to power 3 is equal to minus 3 all raised to power 3. So for finding the cube of the both sides, so we have our value to be s into 1 over 3 times 3 is equal to minus 3 times minus 3 times minus 3. So this will cancel this. X will give us minus times minus plus. Plus times minus minus. 3 times 3, 9 times 3, 27. So the values of x are, so the value of s for these equations, which now give us s is equal to 0, s is equal to 1, and s is equal to minus 27. So this is the value for the value of x, all the three possible values. If you put when s equal to 0, you get 0. When s equal to 1, you get. So when you even put when s equal to minus 27, you also get 0. So don't forget to subscribe to this channel and follow us in our Facebook page, and also share this video. Thanks for watching.